Hey everyone, welcome to video 21.1-A. We're going to be starting our module 21 here, which is all about probability, with talking a little bit about set theory. And there's some really good examples here that kind of walk us through the new symbols that you're going to see in this section, as well as the different definitions. So first of all, a set, as we can see here on page 1083. A set is a collection of objects, basically. A lot of the time in probability we're going to see those objects being numbers, and that's what we see here in our Explore. Each object in that set is going to be called an element, so each number of these lists is an element. And then a set with no elements is called the empty set, and we have braces basically, or brackets, around the numbers that are in our set. If there's nothing in that set, then we have a special symbol, or we have just an empty set, literally, with no numbers in it and just the brackets. The set of all numbers under consideration is what we call the universal set, or if we want to consider that kind of relating to what we just finished doing with geometric probability, this would be our total. So we're using that as U. Identifying the number of elements in a set is really important as far as calculating probabilities. So we're going to do some different set work right now. So in part A it says use set notation to identify each set described in the table and identify the number of elements in each set. The first set, set A, we're told is the set of prime numbers that is less than 10. So if we think about the prime numbers that are less than 10, looks like there are 4 elements in this set, we're being led to believe, and that there's one missing here. So if we think about prime numbers, I hope you can agree with me that the number 5 is missing, so we'll put that in the box. Then we have a new set, set B, which is the set of even natural numbers. Now natural numbers start at 1 and are basically our counting numbers. So the even natural numbers that are less than 10, we have, looks like 4 of them. Let's see if we can figure them out. Even numbers would start at 2, go to 4, go to 6, and go to 8. And there are also 4 numbers of elements in that set, because there are 4 different numbers in the set. Then we have another set, set C, which is the set of natural numbers less than 10 that are multiples of 4. Now remember, multiples of 4 are like counting by 4. So the first one is 4 itself. The next multiple of 4 after 4 is 8, and that is still less than 10. So we can go from 8 to the next multiple of 4, which is 12. But you guys, that doesn't fit in our set because our set description was natural numbers less than 10. So we're going to fill in the blank here and say this is our set C, which is just the elements 4 and 8. So again, this notation, remember, a little n outside of the set name, is just talking about how many elements are in that set, and in this case there's 2. Then we have finally the universal set is all natural numbers less than 10. So the universal set for us this time is all our counting numbers, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And of course the number of elements in this universal set is 9. So those are the sets we're going to be working with as we turn the page to 1084. Let's turn the page now. Okay, on this page, you guys, we have a table that is identifying 4 new vocabulary words that are terms that are used to describe relationships among the sets that we just identified. We can have a subset, we can have an intersection, we can have a union, and we can have a complement. And it's important that you guys understand what all 4 of those vocabulary words mean, and not only that, but the notation that we're going to see, and also what they mean with the examples that we just came up with the sets that we've established. So first of all, notation. If we have a subset, it says C is a subset of B if every element of C is also an element of B. So C is the smaller set, B is the larger set. So what you can see in the Venn diagram is that everything in C is contained in circle B. So I see that little kind of sideways U, almost like looking like a C in that notation there. And so I say kind of C is contained in B is what that notation tells me. But that's my subset symbol. Then for intersection, we have A with an upside down U and then a B. And the intersection of the sets is the set of all the elements that are in both A and B, that are in common, okay? So A intersect B, and that is the upside down U symbol here. The Venn diagram that we have here with our overlapping ovals, A intersect B is just this shaded region. So it's only the set numbers that are in common in both A and B. Then we go to our next definition, which is the union of sets. And the union of sets is everything. It's all of the elements that are in A or B. And so we have A union B, that's the U symbol there. And A union B is all of the shaded regions. So not just the overlap in this Venn diagram, but all of A and all of B put together. And then finally, the last relationship among sets is a complement, you guys. And a complement of a set is the elements that are not in A. So we're going to talk about how we use probability with all of those, but let's use the sets that we used on the previous page to kind of fill in as we go here. For part B, right underneath the table here, we're going to be basically figuring out from the numbers that we just used which ones work. So it says, since C is a subset of B, every element of C which consists of the numbers, remember what C consists of is just the multiples of 4 less than 10, so that's 4 and 8, is located not only in oval C, but also 4 and 8 are also within oval B, because oval B includes the elements of C as well as the other two numbers, 2 and 6. So as I place those numbers in the diagram, they're located in oval B but outside of oval C. So let's go ahead and draw that. So I've got my Venn diagram here where my set of numbers in C is the numbers 4. Well, let me go a little better here and zoom in for you guys. There we go. So 4 and 8 are in circle oval C. Then outside of that, containing all of those numbers but not containing these two, is 2 and 6. And then remember, my universal set is outside of there, and that's all the numbers that you don't yet see in oval B. So we have 1, 2 is there. Remember, these are all my natural numbers. So 1, 2, I need a 3. I have 4, but I need a 5. I have 6. I need a 7. I have 8, but I need a 9. And those are the numbers that are left over out of my universal set. So notice in this Venn diagram, all 9 of the numbers in the universal set are arranged and are represented. They're just interacting differently. Okay? So let's go down to part C. And actually, we just did part C because part C asks us to put that Venn diagram into the table. Part D, now we're going to talk about intersection, and you may want to highlight here. We talked about subset in B, we're talking about intersection in D. So if I want to find the intersection of A and B, remember we need to talk about what overlaps between those two sets. So recall that set A is the numbers, the prime numbers, 2, 3, 5, and 7, and B is my even natural numbers, so 2, 4, 6, and 8. And so if I talk about what numbers do those have in common, I'll circle them. 2 is in common in both sets. Let's see, looks like 3 is not in this set, 5 is not in this set, and 7 is not in this set. Let's go the other direction. 4 is not in A, 6 is not in A, and 8 is also not in A. So the only number they share in common is just the element, the number 2. So on the next page, 1085, and I'm not going to move over there quite yet, but you can see if you're reading on the facing page, 1085, E asks us to take those numbers and again go back and draw a Venn diagram. So let's do that in the second row of our table. So in this case we are starting with, here's our universal set. Here is set A and here is set B, and what we've just determined is that the number 2 is the only overlapping element there. So we're going to put the rest of the numbers in set A into oval A here. So 3, 5, and 7 are the other 3 prime numbers, and 4, 6, and 8 are the other even numbers. So now we need to talk about what other numbers are not being used. Looks like out of our natural numbers we need a 1. Looks like we have 2, 3, 4, 5, 6, 7, 8 all taken up. And so the only natural number less than 10 left out of my universal set is 9. So that would be our example Venn diagram for our second part there. The next interaction between sets, or relationship between sets that we're going to explore, is union. And remember, in the union we take all of the elements of A and B, not just the overlap. As you can see in the Venn diagram, we have all of the ovals shaded in there. So let's just write again what A has as elements off to the side here. This is on the facing page 1085, but I don't want to change slides for you guys and have to go back and forth. So we just have, remember, our prime numbers 2, 3, 5, and 7 that are in set A. And in set B, we have our even numbers 2, 4, 6, and 8. So when we go ahead and do the Venn diagram here for A union B, we have our overlapping circles, and our overlapping circles are still going to have that 2 in the middle, okay? But we're still going to have all of A in A, so 3, 5, and 7, and 4, 6, and 8 are used in circle B. And we still have our outside numbers 1 and 9. The difference is that, you guys, where before we were only doing the highlighted portion here for the intersection, which is just the number 2, in a union we have not just one element but all of these elements. So that's 7 different elements in the union of the two sets. And then finally, you guys, if we just have a simple diagram for our complement here, we know what's in set A, so we'll put those numbers in set A, which are 2, 3, 5, and 7. And very simply, any numbers that are not in set A are what we say are in the complement. So if we go ahead and put those numbers outside this circle, the ones that are not in the circle, Our 1, 2, and 3 are taken care of. 4 is outside the circle. 5 is inside the circle, so we don't need to duplicate that. 6, 7 is inside the circle, and then we have 8 and 9. So if we are highlighting the complement of A, or A with that little almost like an exponent C notation that you see there, we are saying that the complement is everything that is outside of that oval. Okay? So that's set theory, you guys, in a nutshell. We are going to be using that idea of the numbers in sets as we go through and calculate probabilities in the next video.